So I'm waiting some cue from Microsoft to let me know the recording is starting now. Okay, so everyone, thank you so much for having time to join us to see one of our research outcome progress that has done by one of our MyTask Global Link research intern, Mr. Sayantan Paul. And this research is a kind of the initiate research that we are trying to let the computers to understand, to read the many of the full text articles. They are talking about coronavirus from the past to the recently. So the data set is very large. The data set since last March, that is 300 megabyte pure full text data. And in that case, they cover more than 11,000 full text papers talking about coronavirus. And at this moment, the data set has already become 35 gigabytes. And that is covering 223,000 full text data, which is about coronavirus. So from SARS, MERS to the COVID. So what our research wants to do is we wanted to make a computer become an auto question answering machine for any user's COVID-19 question. However, in order to reach that goal, we needed to first of all let the computer to read the data, to summarize some important information based on what he or she sees from the user's questions. And Sayantan help us to do the very fundamental and the very important foundation and the first floor of this research within only 3 months. So he is going to present his research outcome for these 3 months. And by the way, I need to let you know that Sayantan is an undergraduate student in his 3rd year. So within 3 months, what he can do is amazing, and I am proud to introduce you, Mr. Sayantan Paul, our MyTask Global Link research intern, to give us this presentation. Sayantan, the floor is yours.
Yeah. Hello everyone. So am I visible and audible?
Yes.
Yeah. So I'm starting to share my screen. So is my screen visible?
Yeah.
Yeah. So today I'm going to present about the automatic answering service for coronavirus question. So which I have been working on for 3 months. So I am Sayantan Pal from Heritage Institute of Technology, and I'm currently a undergraduate student, which is in India. So I would be first thanking Dr. Maiga Chung as well as MyTask Global Link for selecting me as an intern and giving me this opportunity to work under him. So I did really gain a lot of experience and knowledge in this course and by doing this research. So, and again, thanks to you all for coming here and listening to me, and in spite of your busy schedule, giving the time for me. So thanks a lot. So first of all, let's start by the research goal about this automatic answering service for coronavirus question. So the goal of this research is to having an automated system that will actually identify the keys from the question. So what are the users supposed to do? The user is supposed to ask a question to the service, and the service automatically identifies the key. So what is the key and how I am going to extract this? This would be coming up in a few slides. So after identifying the key, then the service is supposed to generate a relative like associated content that would be related to the question. And then you can see the summary. So then you can also give a feedback according to the summary if you are satisfied with it. So let's see how this is broken into each stage. So here are the 3 stages. So first one is the file extraction and the verification. Next come the data processing, and the last one is the summary generation. So in file extraction and verification, what we are trying to do is basically we have a like compressed files, and we are using a CORD19 dataset, which is from Allen Institute of AI. So we are taking the zip file and extracting only the articles that we need. For example, that zip might contain a lot of images, PDF and stuff, but we are not considering them, but instead the pure text article, which is basically the research paper, which is available in JSON format. So we are extracting that, and then we are processing each of those documents, like converting those pure text data to the thing which we need, and those are being stored to our database. And from the database, then we are actually calculating those, like getting the keywords from the question, and according to those keywords we are fetching the summary from the database. So how we are exactly doing that, we will be seeing in the slides. So let's talk about the first one. So if you can see the screen, I hope you can see this. So this is the stage 1 requirements. So we can see that there is the language and framework that we need for the stage 1. So in stage 1, there is two things. One is the front end and the back end. In the front end, we are basically like taking the help of a web user interface. So for creating that user interface, I'm using HTML5 for the skeleton, and for giving it additional styles, I'm using CSS3 as well as the Bootstrap framework 4, which also makes the page dynamic, as well as I'm using JavaScript for adding functionalities, and PHP, the version 7.2.24 is basically for the backend service, like connecting the page with other pages and stuff. And MySQL is basically for the database, and Ajax you'll be seeing that actually makes a certain portion of the page like dynamic, and it doesn't reload the page every time. So when I be doing the demo, you'll be seeing where I'm using Ajax exactly. So this is the overview of the like stage 1. So as you can see that here is the compressed file, and the structure is something like this. This is some.tar.gz, or it can be some zip file or something else, which contains a lot of JSON files as well as maybe nested tar files. So the first task is to extract all the files, like all the compressed files, into like folders and normal files, which must not contain any more compressed files. So this is the first task. So I'm extracting it and putting it under a folder which is named as .dataset. So in the dataset directory, there are a lot of files like JSON files, PDF files, images, text, and maybe some other format. So the next task which comes is the verification. So in verification, what I'm doing is I'm deleting all the other formats and keeping only the JSON file. And along with the JSON file, I'm keeping one more file which is known as metadata. You'll be seeing why metadata is required. So this JSON file is actually the like research documents. I'll be showing you all an example of this JSON file once. So then I'll be proceeding with the slide again. So let me know that if you can see the JSON document. So can anyone tell me that if you can see the screen?
Yeah.
Yeah. So in this JSON document, as you can see, we have a paper ID. So this is basically the unique like code that we give to that paper. So basically, it's the SHA1 hash. So it can be a case that the JSON file may be renamed multiple times, but we are not getting it by the name, but instead we are getting it by the hash. So we can identify it uniquely. And we are mostly concerned about this abstract part and the body text part. So we'll be seeing this again, like why we are talking about this abstract and the body text. So basically these two part, like the abstract and the body text, contains each of those paragraphs which contains those text. So we are considering this text, and this text will get processed. So this is the reason we are actually talking about the JSON files. So we'll be seeing that in stage 2. So now let's come back to the slide, and please let me know that if you can see the slide again.
Yep.
So thank you so much, sir. So then comes the management dashboard. So once we know that we have like the JSON file, so one needs to see and check and manage that if everything is working properly and the system is actually performing well. So for that, basically there is a page known as management dashboard. So in that page, I am keeping a track of like which database I am connected to, what is the most recent upload. That means that what is the most recent zip file that was uploaded to the service. And also we have like a few things which is in progress section, which is known as the total number of files. Like the total number of file means the total count of the zip file along with the extracted files and all those things. Total number of processed file means the total number of files that has been extracted and verified to. And the current progress, you'll be seeing this live in the like management dashboard, which I'll be doing in the demo section. So these are the information that gets stored in the database. So why are this information again important? Because we must ensure the fact that once we process some kind of zip file, there shouldn't be any repetition. So it should be a unique one, and it should be done once. Otherwise, we will be wasting the CPU like memory stuff for doing that process again and again. So that's why we are keeping a like like storing these things in database. For example, we are storing the file hash that we process so that we can uniquely identify it, and again the start time and the end time, and some other things like the file size and file amount, like how many files it contains and stuff like that. So here is a detailed structure. So whatever I have shown you like previously in the slide, exactly that thing is done using a flow diagram. So what you can see over here is that I am uploading the zip or tar.gz file by the FTP, that is the file transfer protocol. I'm using FileZilla for like my case, and then it gets uploaded over there. And after it gets uploaded, then we run two scripts, and those two scripts run automatically in background using cron. So that is the uncompressed.php and verify. So what's the purpose of uncompressed.php? First, it's check with the database that whether it has already been processed or not. So if it is processed, then just simply delete the file. Otherwise, you just like extract all those files and keep it in that directory, and then delete the tar.gz. And accordingly, this similarly, like we do the same for verify.php. In verify, we basically like take each of those JSON files and then move it to the processing folder. So this is the whole like detail for this stage one. So I'll be showing a demo right now where I'll be seeing like the web interface that I have created, that is the landing page and the management dashboard, as well as the like cron demo. So that cron demo I have recorded previously, so you'll be seeing that right now. So can you see the landing page right now?
Yes.
Thank you so much, sir. So here you can see that this is our landing page. So you all can go here and also check if how it feels to you. And here I have also created a nav bar, so you can see like what the project is all about. And you can also check the about us section and our team section. So here actually more members will be getting added once they start to work in this project too. And here is the FAQ page. So even if you have some kind of question in your mind, so you can once check this kind of question and answers which are already provided over in this section. So this was the demo of landing page. So next we will be going to the management dashboard. So again, this part is not for normal users, but for the admin. So I won't be telling the password over here. So as you can see that in this dashboard, we have like the database name and the most recent upload, as well as the progress, which shows that there is a total of 13,146 files, where 369 has been processed. I mean, this part is the part of stage one, where you can see that we have verified that there is 13,146 document as of now. So obviously there is more, but the system takes time to process and like go for stage two and all the stuff. So I'll be explaining what stage two is and what this process means actually. And as you can see, the current progress is 2.81%, which will gradually grow over months. So this is the management dashboard where we keep track of like how many files are getting processed and stuff like that. So let me go back to the slide again. No, before that, I'll be showing the demo of stage one. So how this everything works. So just tell me if you can see the video. So the video started.
Yeah.
Yeah. So as you can see that in this left section, there is a file known as stage2 part1 10tar.gz. So I can't like maximize the font right now because it's like default in this software and this is a video, so I couldn't do that. So sorry for this small font size. So I am basically uploading it, as you have seen that when I upload this in this FTP, it goes to the right section. You'll be seeing that it gets uploaded over here. So see that came over here. That means basically I'm moving from my local directory to the production server. So this is the tar.gz that got uploaded. And now I'll be like running the cron job. That is, cron job is basically a set of command that basically helps to automate the task. So we'll be seeing how this thing gets automated. As you can see that this is the portion where I am uncommenting the line of uncompress and verify one by one. So the first line over here, like the star, this is basically a command which says that every minute run the process of uncompress.php, and similarly every minute run the process of verify.php. So this hash basically means that the line is commented, so it is not currently active. But when I will be removing this hash from here and saving the file, so that will basically activate that cron job and will install that new cron job. So we'll be seeing that. So as you can see that there is a message known as installing new cron tab. And here in this thing, you can see that the total number of files went from 1 to 2. So basically that one zip got uploaded and extracted 2. So where it got extracted, I'll be showing you in the FTP. So let's go back to the FTP and see, like see here, instead of that zip file, we have that a directory known as number 2, which contains everything what that zip had. So now what I'll be doing is I'll be running verify.php so that like it extracts everything under processing. So see, there is another folder named processing. So 2 will be removed and instead all the JSON file will be moved to processing. So we'll be seeing that too. So as you can see that like I am now uncommenting the line of verify.php. And here you can see that the total number of files will be increased from 2 to the 10 more would be added. So it would be 12. So let's see that happening. So as you can see that the total number of files went from 2 to 12 and the current progress became 16.67%. So that got again automated, and this is the part where Ajax came into play. Here the page is not getting reloaded but automatically changing the figures. So this is why we require Ajax over here, as I told you in the beginning. And we can also see in the FTP that that file got deleted, and in processing all the files are over here. So as you can see, this large numbers, these are basically the SHA1 hash of those JSON files. So this came into processing. So this is the whole demo for stage 1. So let's move back to the slide again. So just tell me once if you can see the slide again. So I'm in stage 2 requirements page. Thank you so much, sir. So now I'm going to talk about the things which are required for stage 2. Stage 2 is mainly more the backend section. So in backend, what we are doing is we are processing each of those documents. So what is the meaning of process? By process, I mean that from those chunks of text, we are taking in the things which we want. For example, we want the sentence, we want a specific n-gram. So what these things are, again, I'll be showing one by one in the slide. So after you have seen the thing that we like require for processing, that was the NLTK packages and stuff. So what we are doing is we are processing this JSON document via a lot of like Python script that is running in the background, and these are also automated again. So this will be running by Cron Job only, and then filling up the tables in the database. So let's understand what are the keywords and like why do we need to understand these things. So first of all, the biggest thing is the JSON document. Then we are breaking it one by one. So in the JSON document, as I have showed you, that there are body and abstract. So in those things, there are paragraphs in each, like maybe in abstract, there is just one paragraph, but in body section, there might be 10 to 12 paragraphs. So these are the paragraphs. Then each paragraph might contain maybe 5 to 6 sentences. So those are the sentence, and those sentence might contain like a lot of words. But here you have to understand what n-gram is and what POS is. So POS means the parts of speech. You can always see the definition written in the slide, and similarly for n-gram. So I'll be like explaining what n-gram is. So consider a simple sentence like I am a boy. So when I talk about n-gram, in our project, we are using n from 1 to 4. Like we are considering from 1 gram to 4 gram only. So let me tell you that what maybe n means. So when I talk about 2 gram, so a 2 gram list would contain like word 2 at a time. For example, when I'm saying about I am a boy, then I am would be the like first like 2 gram, then am a would be the second one, then a boy. Similarly, if I go for 3 gram, that would be I am a, that would be a first one, and the second one would be am a boy, that would be another 3 gram. So this is the thing which n-gram means. And accordingly, the POS list means basically the tagged version of those words. So I getting tagged like PRP, like and then am getting VBP. So things like that. So I am using the NLTK's POS tagger for tagging these things. So now let's see the like what are the information that are getting stored in the database. So I won't explain this in a lot of detail, but the thing which you need to understand over here is this table number 3, like POS tag. This is very important. Like what POS am I storing over here? And I will be again coming to this part in stage 3. So just keep in mind that this like table 3 plays a very key role over here, like table POS. And other than this, in table document, I'm storing some like details regarding the document, and same goes for table sentence, where I'm storing some like details regarding the sentence. And then comes table 4 and 5 and 6. So in table 4, as we can see that we are storing information related to the n-grams, and in 5, and again in 5 and 6, these are like key tables for our summary generation. So in table 5, I'm storing the count of n-gram per document. So this per document word is very important, like count of document, like count of n-gram in a specific document. And similarly, in table 6, I am storing the count of n-grams, like or information about the n-grams per sentence. So that again plays a very key role, like when it comes to stage 3. So just keep in mind about this, like table 5 and table 6. And this is again the structural outline, the whole structural outline for stage 2. So first of all, I am starting the process by pulling a JSON file from the processing folder, and then this process.py is automatically running in background and extracting the data and saving all the things to the database. So this is the whole thing which goes on in stage 2. And we will be seeing the demo of how everything is working in stage 2. So let's move to the demo section. So I'm running the video once again. So let me know if you can see the demo. So this is data processing.
Yep.
So yeah. So again, I'm giving the command and uncommenting process.php right now. So once I process uncomment this line process.php, you'll be seeing a lot of things that change in the management panel as well as in the FTP. So we'll be seeing like what is happening. So I have started the cron job, and once this cron job runs, something will happen. So before I show you like what happens after running the cron job, before that I'm just showing you like what was the initial state of the database that we had. So we can see over here that table document previously contained just one document, and we had like only 106 sentences that got processed from that document. But something like this thing which completely changed after 15 minutes. So let's see what happens after 15 minutes. So after 15 minutes, as you can see that here, instead of that 12 and that 16%, you remember from stage one there was 16%. Instead, we can see that 100% like it got processed, like all the files got processed after 15 minutes. It takes some time to process, and the time depends on the size of the document. So once this thing get processed, we can also see that the tables got updated. Now we can see the table document has 11 total documents. So one was actually previously already given to this database for testing purposes, and new 10 documents got processed. And along with that, we can also see that the table sentences also increased like to 1,838 from 106, and also all the other tables also increased their counts. So what these specifically things are and why are we storing all these things, that will be very clear when I will be going to stage 3 and explaining you like how the summary is getting generated. Then you can understand why these things are equally important. So here I'm actually showing you the size. So we can see that for only 10 documents, we can see that there is the 5 MB size. So you can understand when we will be processing like 10,000 or 20,000 documents, it would be going in GB actually. So this is the thing which I'm showing you over here. And this part I'm actually explaining you how cron works and how each document has got processed. So see the first document, like just ignore the A7 one, just move to the next one because that was already over there. So the cron job actually started from 2F9A. So here you can see that the process started at 16:29:01, and I said that the cron job is running every 1 minute. So we can see that this process took 16:30:19, so it exceeded 1 minute. So when should the next process start? It should start just after 2 minutes. So instead of 16:30:01, it should start at 16:31:01. So you can see that the 59B2, the next document, started at 16:31:01. So this way the all the process starts. And when I'm talking about the second document, so here I'm explaining about the first one. So when I'm talking about the second document, I can see that it ran till 31:45. So when should the next one start? It should start at 32:01. So you can see that 2461, that document had started at 32:02. So this is the way cron is running. So cron is running every 1 minute, but it also waits for us process to stop. It doesn't do parallel processing. If we go for parallel processing, there might be a case that there might be a CPU utilization more than 200 or 300%, that would crash our server. So a code is implemented here such a way so that it processes one by one. Like whenever a document fully stops processing, then the next document starts. So this is the thing which I wanted to show you over here. This is the part of stage 2. This is the way the cron is actually working. And I am just finalizing it, showing you the figures over here once again. So we can see that those figures which I have already shown you. So 11 documents and all the stuff. So this is the way stage 2 is working. So we are processing the document one by one. So this is the video, and then I'm again going for the slides. So I hope you can see the stage 3 requirements right now.
Yeah.
So thank you, sir. So in stage 3 requirements, again, you can see that the language and frameworks are basically from stage 1 and 2. We are using all of them. So I wouldn't explain all of the requirements of everything once again, because these are basically from stage 1 and 2. So you understand that why all these things are required. So this is the overview for stage 3. So let's understand what is your role. So you are the people who are coming and using our service. So that's why, so this part is very important for you all. So this is user, and you are asking a question. So follow this arrow. So first of all, we are checking that whether that question is new or already processed in our database. So if that question is new, then we are sending your question to the our service, and our service is processing or generating the summary. So this processing we will be understanding in very detailed manner, and then it generates the summary and sends it back to you, and it gets stored into a cookie. And if the question was old, we are fetching the summary from the database, and then we are showing the summary that we already had to you, and that gets stored into a cookie. And this cookie part is very important because maybe after 1 or 2 months you want to check that what questions you have asked and what summary you got and what feedback and satisfaction score you have passed. So you can follow this arrow. So you are giving a feedback to the system. So that would play a key role. This cookie would play a key role over there. So this is your cookie. This is the best friend that you'll be having for the history. So what kind of question you asked and what summaries got generated, and like what was the satisfaction and relevance score. So basically a browser cookie stores all the information, and we also provide you a feature known as that cookie acceptance policy. So if you accept the cookies, then basically we store everything, and there are some strict rules also, so you can read the cookie policy for that thing. Then there is the information in the database. So basically we are like, the whole thing over here is you are anonymous. We are not storing anything related to the user. We are not even asking a question or something like that. We are basically giving you a UUID once you accept the cookie and ask a question. So once you do that, so we are giving you a UUID, and we are identifying you by that UUID each time you visit the website. So none of your personal information or your question gets public or like stored, but instead we are storing this question and summary anonymously, because for the improvement of the system. And along with that, you are given a UUID. And other than that, the table 3 is for like for our next stages, where we will be going for the satisfaction and relevance and accordingly modify some or maybe optimize some more things. So this is the thing for information in database, and this is the outline. This is the structural outline, as you can see. So you are coming to our website over here, and then you are asking a question. So first of all, if you already have asked the question, that would be in your cookies section. So you can find that and you can reload the summary. Otherwise, you can ask a new question, and accordingly we will be generating from that answer.php. It's a script, and from that we will be generating that summary by processing. So what is meant by processing and what will be happening, I'll be show you. And then from after the summary generates, we basically send that summary back to you, and that reloads the summary to you. And then you can you have an option to give feedback. So if you don't give a feedback, we don't mind, but we would be very happy if you do so and give a feedback. That feedback gets stored in our database. So this is the outline of stage 3. So let's do a live demo. So I'll be showing the user interface as well as the summary generation and the cookie usage. So let's see one by one. So I am loading the page of user interface. I hope you can see that. Yeah. So again, first of all, I'll be asking a question over here. And as you can see that here, you can see the cookies over here. Right now, this is a completely new session I have done. I've cleared all my cookies. So you can see that it's completely new. And over here, there is something known as question summary, where the question would be displayed as well as the summary would be displayed over here. And once you give a feedback, that would also be displayed. So this is the first time I'm asking this question, and this question hasn't been processed in our database yet. So you'll be seeing that it will take some time. So let me ask this question. So when I'm asking this question, you can see a pop-up, this green pop-up, where you can see that if your question has a word count less than 5, then it will take approximately 7 to 8 minutes. If your question has a word count between 5 to 10, it would take around 10 to 15, maybe 10 to 12 minutes. And if your question has a word count greater than 15, then it will take greater than 15 minutes. So why this will take so much time and why this will be happening, we'll be understanding the time it will take to process. So during this time, we'll be understanding everything, how everything is going on. So I'm back to the slide. So can you see the understanding how to identify keywords page?
Yeah.
Thank you, sir. So here, as you can see, that this is the question that I have asked: is COVID-19 deadly? Will it ever vanish? So accordingly, so we have to understand that what are the keywords over here. So we can see that I have colored some words known as COVID-19, deadly, and vanish. These are the colored words. So these are the words which are the keywords. Now the next question comes, how are we identifying that these are the keywords? So for that, remember I have told you to remember the table 3 from stage 2, which contained the POS. So we have to identify that which would be the eligible POS. For example, we from common sense, we know that nouns and adjectives, these are very vital and may be very significant for that. But we have to prove it somehow that, yeah, these are actually very significant and it would be the keyword. For that, the POS that I have considered are these ones that you can see in the screen. And there is a reason why I've considered only this one and not all. So you can see that there is an analysis of all the JSON docs that I did, but not that this is not the part that I had during my internship period. So this is actually a separate research itself. And 2 of the parallel research are going on right now over this section, what would be the POS tags, what should be the eligible POS tags, and accordingly I'll be using that service created by the other researchers in my project. and for the time being, I couldn't proceed with so many like POS tags. You can understand that here I have shown that there are 36 POS tags. So if you think like if n equals to 1, 2, and 3 and 4, accordingly we will be seeing this many combinations. So that would be 36 plus 36 square plus 36 cube and 36 to the power 4. So when we'll be adding these numbers, we'll be seeing 1.7 million POS tags. So if we consider this 1.7 million tags and do not filter them out, then what will happen is this the time for generation of this summary would be exponential. So we can't do that. So instead we have to go for a filter which would take about 15 to 20 tags or maybe less than that. So the lesser tag you take, the like faster it would be for generating those vectors. So what are vectors and how what I'm talking about you'll be seeing in the next slide again. So basically you can understand like this, that the lesser number of tags we have, the faster we can do that, but it doesn't ensure us that the summary would be great or like highly good or like you'll be satisfied with that summary. So if you want to check that notebook, you can always go to this link and check like what was the analysis that I did over there. I have taken 2 documents into consideration just for filtering out and finding out these 16 tags which might be useful for us in this project. So this was the analysis that I did, and these are the actually ongoing projects that I was talking about. So one of the project is being done by a research member of our group named Mr. Bhavesh Gandhi. So he is basically like processing or extracting the n-grams and the POS tags from a huge dataset known as DBpedia. It is kind of similar to Wikipedia, but like it's known as DBpedia, which contains like 5.2 million chunks of text. And from that text, he will be analyzing and extracting n-grams and their corresponding POS tags, and he will be sending me a service. Like he will be providing a service for my project so that I can use his service to know what are those eligible POS tags. So this is coming up in the end of August. So if you are curious about this, so you can always stick to like maybe schedule some plan so that you can attend that presentation too. So this is one of them, and another one is being done by Mr. Dan Boonstra, where he's going for statistical analysis of this CORD19 dataset and accordingly generating the eligible POS tag. So it doesn't only like in my case, I have just considered about the frequency, but in this research, he's not just considering the frequency. Instead, he's applying a lot of statistical methods to analyze what would be the eligible POS tags. So this is again an ongoing research that would be helping me for improving my system. So then comes the stage like 3, where I am showing you the like how the summary is getting generated and how everything is working. So let's understand this very like clearly. So I have told you that these are the eligible n-gram list. So this COVID-19 deadly and COVID-19 deadly are 2 gram, and this vanish is again a 1 gram. So here you can see a target vector. So now what is a target vector? Target vector is basically the frequency of each of these words in our database. So these numbers are again, I have like given from my mind. These are not exact numbers. So basically I'm trying to tell you that this COVID-19 has maybe appeared in our database 85 times. Similarly, deadly might have appeared 58 times. And this COVID-19 deadly might have appeared 20 times and vanish might have appeared 25 times. So this is my target vector. And similarly, I'm then calculating the document vectors. So how am I calculating document vectors? So you remember the table 5 of that stage 2, where I have said that I am storing the count of n-gram per document. So from that table, I am actually fetching those counts and accordingly creating this vector. So this basically means that document 1, so that document might have 35 like COVID-19, like frequency of COVID-19 might be 35 over there. Similarly, deadly might have 25, and these others might be 10 and 12 respectively. So these are the vectors that I'm generating, and you can understand that if the like vector length goes like the larger the vector length would be, that more time it will be taking for calculating the cosine similarity. And one more thing is that the number of documents, the more documents you'll be having, so the time would increase. For that, we have to go for some kind of optimization, but that would be coming in part 2 of this research. So this is the part 1, which had 3 stages. So we are more focused in generating a summary than going for optimization and providing much more efficient algorithm for maybe generating the generating the summary, like faster method. So this is the part where which goes for document. And similarly, you remember table 6, which I said that we are storing information per sentence. So from that table 6, we are actually generating the sentence vectors. So let me tell you that first of all, when I am doing a cosine similarity of this target vector along with this document vectors, I am getting a score between 0 to 1. So once I get a score between 0 to 1, the maximum score that I get, that would be the best and the most similar thing that would be close to the target vector. For example, maybe this document 1 is the best one, like to the target vector and the closest one. So I select document 1, and then I again from that document 1 I process all the sentences over there. So that document might contain maybe 100 to 150 sentences, and I create those 100 to 150 vectors. And from those two vectors, again I do that same thing, and I do cosine similarity. And from that cosine similarity, maybe I get sentence 1 and 2 as the best match, and I basically concat them in order, and then that would be our summary. So this is the summary. How the summary is getting generated. So if you want to know what is cosine similarity and how everything works, so cosine similarity is actually a mathematical formula where it doesn't consider the magnitude, but instead we are much more curious about the angle. So for example, we can see that V is our target vector over here, and D1 is the document that is the closest over here. So we are selecting D1. Then after selection of D1, then what we are doing is this would be that D1 document where we have that V vector, that's the target vector, and we have S1 and S2, which has, as you can see, the least the closest one. This is the least angle, so that would be the closest one, and accordingly the cosine similarity score would be close to 1. So we are picking out S1 and S2, and again concatenating these two for generating the final summary. And again, this would be the future of the research. So using a service to get the list of eligible n-gram POS tags and reducing the amount of time to generate the summary, as well as generating a better summary. And I will be showing you that what happened over there, because I have processed a question. So as you can see that the question that I had asked, I get a answer also. So the question I asked was, is COVID-19 deadly? Will it ever vanish? So the summary I received is based on COVID-19 numbers for COVID-19. Death rate 2 to 3 per 100. The new coronavirus appears less deadly than SARS or MERS, but more deadly than the seasonal flu. It is uncertain whether COVID-19 will vanish, similar to SARS, or become an established disease that follows seasonal patterns. So how this got generated? So here you can see that this word deadly. You can see that here the keyword has been found deadly 2 times. Similarly, if we go for COVID-19, okay, so if we go for COVID-19, you can see that has been found 1 time. I don't know why it is not taking it, but we can see that it has been found 2 times actually. So here you can see that COVID-19 has been appearing 2 times. Similarly, vanish has also appeared 1 time. So this is the way it identifies the keywords, and then according to the keyword, it processes and generates the summary. So this is just one of the question, and it takes some time. And accordingly, you can also see that this is the the UUID that has been provided, and this keeps your session anonymous too. And we are recognizing you by this UUID. And I have told you that this is the cookies section where you can see that the question you asked has been stored. And currently it is also showing that you haven't provided any feedback. So let me provide a feedback once. Maybe I will set relevance and satisfaction to 9 and 9. And I'll be giving the feedback right now. So you can see that the feedback has been provided, and the relevance and satisfaction is also showing. And I'll be asking a few more questions to this service so that you all understand how the system works. So I'm asking the next question, and I have actually, first of all, already asked this service this question so that the summary already gets generated. Otherwise, it would take a lot of time, and I wouldn't be able to finish the PPT on time. So I'll be asking a new question right now. So as you can see that it instantly gets generated, the summary instantly gets generated. So you can see that can coronavirus survive on surface? So we can see that the summary is not that reliable and not that satisfiable. So you can see that a thing which has been provided over here is that exclusive requirement of mn+2 for the synthetic activity. So we can understand that yes, something, it is relevant at some level, but not exactly what it looks like. And why it happens, as I have shown you in stage 1 during the management dashboard, that there were 13,000 documents, remember, and that was just only a document that the zip file was actually of March 2020, and that zip only contained 13,000 document, and that from the 13,000 document we have been able to process only 369 because this project is again in a development phase. So once it processes a lot more, maybe 11,000 to 12,000 document, then our summary would be more viable and maybe reliable too. But again, we have to go for some optimization techniques so that the summary gets generated faster. So here again, I can set some maybe relevance to 6 level and satisfaction to 4 and submit that again. So when I submit that, you can see that the feedback has been provided and relevance and satisfaction has been set to 6 and 4. So now suppose I'm asking one more question just to show you that maybe how does the virus spread. So again, I'm asking this question, and as the summary has been already stored, so it loads the summary directly from the database. And again, it shows that no feedback has been provided. So suppose you don't want to give any feedback over here. Instead, let me like you come after 2 months and you want to see that what was the question that I have asked. So you can click in this drop down and you can select like the question that you want to view. For example, you want to see this question only: is COVID deadly and it will ever vanish or not? So when you press the submit button, it automatically loads your summary, and as well as it loads the satisfaction and relevance. So now you have a choice to again like submit a new feedback. So in future, what we'll be doing is, in future we might show you a different summary next time you like ask a similar kind of question, and from there you can always update this satisfaction and relevance and submit a like new score. Maybe you are satisfied with your score, maybe you get 10 or give 10 or 10, and sometimes the summary might not be that relevant. Maybe the next summary you can see the next time you ask this question that might not be relevant, so you can give a relevance and satisfaction of 7 and 7 and submit that. So we will be like, when you do that, so we can again see that the relevance and satisfaction has been set to 7 and 7. That would be again stored in our database, and accordingly we will be understanding that this new summary isn't that relevant to the previous one. So we can again do some kind of modification, and that would be a part of future research, as I have shown you in the slide. So this is the thing that I have to show you in stage 3, and this is the part of cookies that I've also shown. So let's move back to the slide, and as you can see, I hope you can see the future research page of this slide.
Yes.
Yeah. Oh, thank you, sir. So you can see that again we are like, I have shown you that the ongoing research for those POS tags. So when we get a like much better list of POS tags, we are expecting that we will be getting a better summary, and we can also apply some kind of optimization to like reduce the time and generate a better summary. So if you have any questions, you can always ask me, and thank you so much.
Thank you. Thank you so much for the presentation. And do anyone has any question? Okay. So just very quickly, because I believe that John is going to leave, and one question from John is about whether or not this system is ready for use. And Sayantan?
Yes, sir. You can hear it. First of all, the system is ready for use. So, like, if you are like helping us to like improve this research, this is always ready for use. And like at this point of time, you might not be able to see a like very good summary of like the question that you asked. It might not be that relevant, or you might not be that satisfied with the answer. But there is a reason for that I have told you, that there is currently 369 documents right now in our database, and maybe after a few months that might be reaching thousands or maybe 2000s. So you might expect a better summary, but you have to like keep in mind the time factor, because if you ask a too long question that might contain maybe 7 to 10 keywords, that would take some time to process, and accordingly it might be 7 to 8 minutes, or sometime maybe beyond 10 minutes to give you the summary. So if you are like okay with that, then you can always use the system to ask the like, or if you like ask your question. But if you don't have time and you are heavily dependent, if the system performs within 1 minute or gives me the summary within 1 minute, then you have to wait for a few months, maybe, where we will be improving the system by going to the next phase of this research, and accordingly you can see a better like faster like time for summary. So if you are okay with that, then you can always like ask the question, and we will be more than happy for that, because we will also be able to analyze like what are the like downsides of our system, so that we can work on that and improve the system. So yeah, thank you so much for asking the question.
Wonderful, thank you for that. I must leave for another meeting now, but great system, well done.
Thank you so much.
Thank you. And so basically, I think there is also one question from Viva. Probably he has already gone, but one of the questions he asked is, let me see. Actually, let me see. Okay, actually that is also coming from John. So how smart is it in identifying reliable source? So, for example, does it can distinguish clinical trials from RCT, an abbreviation word?
currently in the question you have asked is basically comes to the text processing section. So how have we processed our document? So how has been the pre-processing done for each of the sentence? So right now I am just removing those things which are absolutely not useful. For example, maybe some kind of symbols or punctuations and maybe some quotation mark which might create a problem while inserting in our SQL database. And right now, nothing has been implemented for abbreviation. So we might take into consideration of this, and maybe in the next stages we can go for that kind of abbreviation. Currently, the system doesn't support abbreviated text. So if you provide some kind of abbreviation, it will only work if that abbreviated word is present in that document. So there might be thousands of documents, and it has a high chance that it actually contains some abbreviated words. So if it is present over there, then you can always expect that you will be able to see that. So yeah, this is the thing, that's the way it works.
Yeah. So I also see there is another question from Stephen. I think his question is okay. First of all, this question, I think Stephen, you can find the answer to see. His question is, what if I given the system a question like if I get the COVID and take a Tylenol, what is my outcome? So so basically, of course, because we are not a system, so we don't know the answer. So Stephen, you can try that question and see what you will get. But just like Sayantan mentioned, because right now the system only, if you see the earlier demo, the system only have read 300 maybe 69 papers. And remember, those papers coming from the first batch of the data set, which is published in March 2020, last year, which means those papers, almost all of the papers in the first batch, they are about coronavirus in the past. So it's like SARS, like MERS. So it may not have papers regarding COVID. And on the other hand, right now in July, the data source has already covered 223,000 papers published before. So those papers, many of them, they will be related to COVID-19. So that is what you may need to remember, because according to what kind of documents the system read, I'm hesitating saying learned, so I say read. So depending on what kind of documents they read, they will provide you what are the answers they think are more related to your question. Unfortunately, as you can see, like earlier John's question, Sayantan mentioned, right now we didn't consider the semantic meanings of the words. So we probably also don't know the control trial. Actually, random control trial is the abbreviation word RCT. So in that case, when the system trying to give you the answer, actually he or she will not doing any kind of induction or deduction or conduction or anything like that in inference your question. He or she is just trying to find the most similar or the sentence that also mention the similar things in the paper. So that is what happened. I see there is another question from the Dr. Oscar Lin, and he asked you how many users can ask a question to the system at the same time.
Yeah, this is a good question actually, and you can consider, like when I was testing, I have currently like tested with 5 at same time. So you can expect 5 would be working at same time. But if you expect that like I'll be saying 100 of users would be coming and asking at the same time, then the server might crash. So it would be like, because the CPU utilization will increase. Basically, what is happening if and one more thing, if the question is new and 100 users ask new question, then only this will be happening. Otherwise, we will be just fetching it from the database and that won't take a long time. But if the question is new, that would involve processing, and for processing we know that there might be a scenario for CPU utilization and other like resources like memory and stuff. So if it exceeds the limit that our production server has, then it will obviously crash. So that is the answer to the question. So if you actually provide it to a better production server where there are more resources and it is able to handle like many users, so that would be an industry level stuff, not a like research where you get a limited kind of resource. So there you can always do that. So that won't be a problem. So
yeah,
we don't have a limitation from that side.
okay. Thank you so much for the answer. In that case, Oscar, Ali, we need a better production server.
Thank you.
Yeah,
Thank you.
because right now the server actually is running on the virtual cloud server, and of course we don't pay anything, which means the performance of the server may not be so good like a real industry commercial website, because their server may be having 8 CPU, 32 gigabyte RAM or something like that, but we don't have. So yeah. Yeah, so yes, Ali, the question, can AWS help? It depending. I would say if we are using free AWS service, then that will be even worse. Because free AWS virtual server is a very, very, very low computing resource, and it will also pause your system if you use their CPU too much. On the other hand, Google Cloud Computing Service and the Microsoft Computing Service, they allow you to surpass the CPU. So in one of our research project done by Anirudh, actually we have 30 minutes trying to use CPU more than 150%, and then another 30 minutes using 100% CPU with Google Computing Platform, and it can still work. But in AWS system, if you are using free license, which means you don't pay, then the server actually will refuse to work for about 10 or 20 minutes once it's find that you use too much resource. So if we have paid AWS service, then definitely it help. One question from Stephen. I'm not quite sure if Sayantan you want to answer or you can answer. So the question is, have you considered using transformer to compare your current implementation?
No, we haven't done that yet, but we might always go for this kind of stuff in next stages. As I have told you that the main thing we are focusing is right now, first of all, the automation, and secondly, the summary generation. So the thing which we are like wanting right now is getting a summary. It's not about the optimization or algorithm or applying any kind of transformer or maybe preprocessor so that we get maybe a filtered text or something like that so that we can do it faster, or a maybe valid and better summary. But instead we are just wanting the summary, because this is the first part of the research, and I was actually like given the task of going for the summary, not exactly other things. And in 1 month of time, implementing those and deploying in production and doing that stuff is like it takes some time. So yeah, so I'll be going for that in maybe the part 2 of the research. So the second floor, as sir says, so in that we will be building this kind of stuff. So yeah, thanks a lot for the suggestion again. So we'll be doing.
Yeah, thank you so much. Yes, just like Sayantan said, first of all, I want to use the remaining time to congratulate and thanks for the Sayantan did within 3 months. You need to remember he started this research on May 1st. And now is July 30. So only within 3 months, he completed so many tasks and provided the research a very good foundation, and even first floor. So the foundation means we can make a computer to start to read all the articles we have. And remember, although this research is about auto answer machine for COVID-19 or coronavirus question, but consider that if we can use the same foundation to read all the learning materials about Java programming, or learning material about physics, then the system can provide a summary for students about their question regarding physics. And for the time spent, because right now we are using very simple way as a foundation, that is cosine similarity plus POS and n-gram. But consider that if we are not doing this with web-based system, how about we develop this as a kind of chatbot? So in that case, you can consider if students or people, they want to ask some question, they talk to someone in the chat or in the Facebook. So you know, when you post something on Facebook, you don't expect to see the real-time outcome, real-time response, right? So that is very similar things. If you use this system in Facebook, and you consider this system is a human being, no one knows that actually it is a system to answer your COVID-19 question, but something like ask a doctor, I don't know, I cannot have some name, but maybe SP, because this first of all is created by Sayantan. So let's say ask the doctors SP, and SP will not always be online, so they will answer your question when they are online. So in that case, waiting for 5 minutes, 7 minutes, or 15 minutes to get your answer, that is maybe reasonable. So so that is another story. So depending on where this application is going to put, if you put this application in Google, like a Google search engine, then you will be not very happy with Google search engine's speed. But on the other hand, if you consider that is a human being on a Facebook or a human being in a chat, then they may not respond to you very quickly. Anyway, so I want to thank you, Sayantan, for anything you have done. And I see Stephen has raised his hand, and also actually he has already turned on his microphone. So Stephen.
So just one question, if you guys can hear me. The output of each of the stages, I think you had 3 or 4 stages there. Will that data be available? Like, say I wanted to play with it if I have 5 minutes on a Saturday afternoon when it's raining, or in this case, smoke is heavily in Calgary.
Yeah, you can actually always test our service, but we are not giving the source codes that we have for each of the stages. But if you want to test our service for maybe the stage 3 is actually the part where user comes in action and wants to try the service. So you can like test our service. It's always open and public for everyone. So yeah, you can test the service. So
I mean, just the data, like you've done a whole pile of work to extract from all this sources, just like the raw output, like that type of setup. Would that be available, or is that still in progress?
No, it can be made available, but it actually depends on my supervisor if he might allow to give that like extracted data. And first of all, like another question is that during the extraction, what we are doing is we are putting it directly to the database. So it's not in a text file or something that I can zip it and send you like that. So it's all in the database, and that database contains other research projects too, which are a bit confidential. So I don't know at this moment if we can like show you all the database stuff which are going.
That's fine. I mean, you've got looks like many more months of work on this. So, but just as you gonna work it through, like there's different components. You say, well, I've got data extracted. Okay, there's more than one algorithm to go from the data to the QA, right? That would kind of be that stage, right? And then you guys can put filters on, that kind of stuff, and you could even put like a Flask REST API on or something, those kind of things with a password on the front end or something. Like those are future things, right?
Yes.
Yeah, because there's a tremendous amount of work you've done already to get it from the raw form into the database, which I do appreciate.
Thanks.
No, I know. I work with this stuff all day long. It's a big job. Appreciate the work you guys are doing. I'm the industry side of the world, so I look at the world and go, thanks. Appreciate what you guys are doing.
Thanks a lot.
Thank you so much. And Yeah, I think we have finished our presentation, and once again, thank you all to join us. By the way, I want you to know that in August, in the end of August, we will have maybe another 3 presentations from other research. So, so in any case, if you want to join any of them, you can write me an email so I can put your email address in my invitation list. So I will send you this advertisement, or you can consider that it's a kind of flyer to see if you want to see our research. And also in the beginning of September, probably we will have another research outcome coming from Scott. So basically, usually we will have a seasonal research presentation. So this season is starting from yesterday and today, and then the end of August, and perhaps in the beginning of September, and then I will hope to share with you our research outcome in the next season. Okay, so once again, thank you everyone to join us, and this recording will be available for some of you if you want to double check later.